Hello everyone. So yesterday, as I told you, today we will be working out examples, right? So note down the questions fastly. You need not note it down as such, just roughly you can note it down. Because these are just questions only, you can roughly note it down. Try to get the answers. First question. Which of the below has linear shape? Which of the below has linear shape? NO2 plus, XeF2, I3 minus, I3 plus. There could be multiple options also. Questions may have multiple options also. Okay, so what is the answer? Which one? NO2 plus. Nitrogen has 5 electrons, but 1 electron is lost, 2 oxygens. Steric number is 2. It is existing as 2 plus 0. Sp, linear. It is Sp and linear. So what is your question about? Which of the below has a linear shape? First one, do you have a linear shape? Yes. So first one is an option. Next, XeF2. XeF2. Is it having a linear shape? 1, 2, 3. Altogether steric number is 5. That 5 is existing as 2 plus 3. That 5 is existing as 2 plus 3. So what shape does it has? Linear. You need not consider the lone pair. It is also a linear one. XeF2 is linear. First one is linear. I3 minus. It is also linear. We have done it. I3 minus. Minus charge. Again steric number is 5, 2 plus 3. So 5, 2 plus 3 means it should also be linear. I3 plus, linear. Central atom is iodine. 7 valence electrons, 1 is lost, 6 valence electrons, 2 iodines. Steric number is 4, existing as 2 plus 2. It should be bent or angular. So what is your answer? They are linear. Okay. Next one. Which is true about NH2 minus, comma NH3? Which is true about NH2 minus, comma NH3, comma NH4 plus? NH4 plus. Write the option. Hybridization of nitrogen is same. Hybridization of nitrogen is same. Number of lone pairs on nitrogen are same. Number of lone pairs on nitrogen are same. Molecular geometry means shape of the molecule. Molecular geometry is different. Bond angle is same. So which is true about these three? Whether hybridization is same, lone pairs are same, bond angle is same, molecular geometry is different. hybridization is same. C is molecular geometry is different. But what are same? Okay, let us look at the hybridization. How many electrons? Directly I am writing 6 electrons. Nitrogen has 5 minus 1 charge. There are 6 valence electrons. How are these 6 valence electrons distributed? As you practice slowly, every time you need not write all these electrons. What is the steric number? 4. It is existing as 2 plus 2. 2 plus 2 is angular. NS3, steric number? Steric number is again 4. 3 hydrogens, 1 lone pair. It is existing as 3 plus 1. So here what is the steric number? 4. 4 means sp3. What is the steric number? 4. sp3. Here what is the steric number? 5 hydrogens, but 5 electrons, but 1 is lost. 4. So again steric number is 4. Hybridization is sp3. It is existing as 4 plus 0. When it comes to molecular shape, this is angular, this is trigonal pyramidal, this one is tetrahedral. So molecular geometry is different. Steric geometry is same. Steric geometry is same, or electronic geometry is same, but molecular geometry is different. Okay, hybridization is same. So in your options, what is true means hybridization is same. Number of lone pairs, they are not same. In this case there are 2 lone pairs, 1 lone pair, no lone pair. That is also wrong. Molecular geometry is different. Yes, molecular geometry is different. Bond angle is same. No, bond angle is different. Next, identify the correct option. Identify the correct option. Identify the correct option. First one, write down the option. Order of the bond angle. First one, order of the bond angle. Identify the correct options. Which of these is correct option? Which of the 3 is correct? Which is the correct option? A. Is this the order of the bond angle? This is 109. NS3, it is anywhere around 107. NS2 should be lesser than that because there are 2 lone pairs. So it is lesser than 107 degree. A is true. Next one. BCS3 taken thrice. You just take CS3 in plane. Okay. You just imagine that they are in plane only. It is trigonal planar molecule. That is also true statement. It is also a true statement. It is a trigonal planar molecule. 3 methyl groups. In ammonium chloride, nitrogen atom is in sp3d hybridization. It is in sp3. sp3 or sp3d? sp3d. Ammonium chloride is NH4 and Cl minus. It is NH4 and Cl minus. This is a cation, this is an anion. So there is an ionic bond between them. Now around this nitrogen means you have to check in NH4 plus. Is it in sp3d? It is in sp3. It is in sp3. So the last statement is wrong. Don't consider chlorine because it is not a covalent bond. It is not a covalent bond. Okay? Finished? Okay, right, take down the next one. Match the following. Match the following. You may have multiple options also. You may have multiple options. ClF2 minus 8 electrons altogether, 2 fluorines, steric number is 5, that steric number is 2 plus 3. So 2 plus 3 means what is the hybridization? sp3d. It is linear. You can also write TBP. TBP is electronic geometry. Every information I am writing. ClF2 minus. There are 3 lone pairs. So 3 lone pairs will come in the equatorial position. These are the 2 fluorines. So molecular geometry is linear, but electronic geometry is trigonal bipyramidal with sp3d hybridization. That is ClF2 minus. ClF2 plus ClF2 plus 6 electrons. Steric number is 4. It is existing as 2 plus 2. 4 means sp3. Shape is angular, but steric geometry is tetrahedra. Now come to the first one. What could be the geometries? You got linear and bent. It means they are referring to molecular shape. So this is linear and angular or bent, anything you can call. It means you have to consider the molecular geometry. So for first one, I am putting an option. I am just putting it here. First one is sp3. Finished? Note it down fastly because we have many more questions. For second we are getting some answers. Seesaw, pyramidal. Second one, IO2 F2 minus from Dhanalakshmi, 2 and 2. So B is 2. IO2 F2 minus and F2 SeO. Iodine has 8 electrons, 2 oxygens, 2 fluorines and 1 lone pair. 1, 2, 3, 4, 5. Steric number is 5. It is existing as 1, 2, 3, 4. 4 plus 1. 5 means sp3d. So what is the geometry? It is seesaw. You also write TBP because for 5 steric number the electronic geometry is TBP, but it is existing as 4 plus 1. Therefore it should be a seesaw. Next, selenium. One, 2, 3, 4. That 4 is existing as 3 plus 1. So it should be sp3. It should be pyramidal. Or you also write tetrahedra is the electronic geometry. So you got seesaw and pyramidal. IOF4 minus 4th square pyramidal. Now directly we'll do. Iodine has 7 electrons, 7 plus 1 is 8 electrons. Out of those 8 electrons, 4 are bond pairs with fluorine. 2 more electrons are participating with oxygen. So 6 electrons are gone for bonding. But how many bonds are there finally? 5. Oxygen is taking a double bond. Out of 8 electrons of iodine, 6 electrons are participating in bonding. You are getting steric number of 5. One more electron pair is left out, 6. So steric number is 6. It is existing as 5 plus 1. Steric number is 6. It is existing as 5 plus 1. 6 means octahedra. 5 plus 1 means square pyramid. Square pyramid. Okay. Next. XeOF2. 8 electrons are there. Out of 8 electrons, 4 electrons are participating. 2 for oxygen, 2 for fluorine. Out of those 4, 3 are bonds because multiple bond is taken as one domain. So 3 domains coming from the 4 electrons. Remaining 4 electrons, 2 pairs. So what is the steric number? 5. Steric number is 5 altogether. That 5 is existing as 3 plus 2. So what is 3 plus 2? T shape. That is T shape. If anyone is finding difficulty, IOF4 minus altogether 8 electrons, 1 oxygen, 1, 2, 3, 4, 5 and 6. That 6 is existing as 5 plus 1. So square pyramid. Hybridization is sp3d2. Electronic geometry is octahedra. Next one, XeOF2. Xenon, 8 electrons, 1 oxygen, 1 fluorine, 2 lone pairs, 1, 2, 3, 4, 5. Steric number is 5. It is existing as 3 plus 2. For 5, it is sp3d hybridization. 3 plus 2, T shape. Electronic geometry is trigonal bipyramidal. BRF5 square pyramid, XeOF4 square pyramid. Okay, both are square pyramid. BRF5 is square pyramid. XeOF4 is also square pyramid. Steric number is 6 existing as 5 plus 1. 6 means sp3d2, but it is 5 plus 1, therefore square pyramid. And electronic geometry is octahedra. XeOF4, xenon has 8 valence electrons. 1 is oxygen, the remaining 4 fluorines. 1 lone pair, 1, 2, 3, 4, 5, 6. That 6 is existing as 5 plus 1. 6 means sp3 d2. 5 plus 1 means square pyramid. Electronic geometry is octahedra. You can note down another question. The species having bond order, the species having bond order different from that in CO, different from that in CO. Bond order different from that in CO. So bond order should be different from that of carbonyl. See, there are some questions for which you need to respond fastly. They could be simple questions only, but only thing is in which time you are responding. That is important for us. Which one? C. Still? Any other options? A. One. C. It should be different from that of CO. So simply how should you work out such questions is, how many electron system is CO? 14 electron system. Simply it is a 14 electron system. How many electron system is NO? 7 plus 8, 15. 15 plus 1, 16. This is a 16 electron system. Cn minus 14 electron system. NO plus 14 electron system. N2 14 electron system. Now what is your answer? A. Simply A. Because the remaining 3, they are isoelectronic. Once they are isoelectronic, bond order will be the same. Right? For all these isoelectronic species, bond order will be the same. Isoelectronic means all are having 14 electrons except this, which is having 16 electrons. What is the bond order of this? NO minus. This is 3, this is 3, this is 3, this is 3. NO minus 2.5. NO minus is 16 electron species equivalent to oxygen 2. Bond order is 2. Okay. Write down another question. The structure of XeO3 is, the structure of XeO3, linear, planar, pyramidal, T-shape. Now respond fastly. The structure of pyramidal. XeO3 is pyramidal. So immediately by looking at it, 8 should come in our mind. In that 8, 6 electrons are participating in bonding, but you are getting only 3 steric number from that. 1 lone pair. It is just equivalent to ammonia. It is just like equivalent to ammonia. So Xe, it is pyramidal. Next question. Assuming that Hunt's rule is violated. Assuming that Hunt's rule is violated. Hunt's rule is violated, comma, the bond order and magnetic nature of B2 is, assuming that Hunt's rule is violated, the bond order and magnetic nature of B2 is. P represents para, D represents diamagnetic. Bond order is 1. Yes, we are getting some options. B. Some are giving A, some are giving B. From your side, which is the option? Hunt's rule is violated. So when I say Hunt's rule is violated, this is 1s, 2s, 2p. Boron and boron. How many electrons are there altogether? 5 plus 5, 10 electron system. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is regular. But when Hunt's rule is violated means you put 2 electrons here. You are just putting 2 electrons here. Hunt's rule of maximum multiplicity. When they say Hunt's rule is violated means maximum multiplicity is not there. So go for the minimum multiplicity. What is the bond order? Number of bonding electrons 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So bond order is 1. But is it para or dia? Now it has become dia. Suppose if it is following Hunt's rule, it is paramagnetic. It is not following Hunt's rule, therefore it is diamagnetic. So 1. Bond order is, yeah. Okay. Actually it should be 1 and D. Both have given 1 and P, 1 and P. One of them you make it as D. Because both are 1 and P, 1 and P. It is not both. One should be diamagnetic. 1D, 0D, 1P, 0P. First one should be D. Note down the next question. This you have to answer fastly. The species having pyramidal shape. The species having pyramidal shape. The species having pyramidal shape. B is not the option. D. Is D option? D. BRF3. That is pyramidal. BRF3, is it pyramidal? It is existing as 5, 3 plus 2, T shape. Sulfur 6, oxygen, fluorine 1, 2, 3, 4. Steric number is 4, existing as 3 plus 1. Therefore, this should be pyramidal. SO3, steric number is 3, existing as 3 plus 0, trigonal planar. So your answer, anyway we got it, OSF2. OSF2 is right. Now more quickly, the shape of XeO2F2, I am not even giving you the options. Directly tell me the answer. The shape of, they are asking shape. Shape means not electronic geometry. Shape means molecular geometry, remember. The shape of XeO2F2, TBP, square plane, tetrahedra, seesaw. Square plane, it is seesaw, yes. Seesaw is right. Okay, seesaw is right. Everyone is answering very fastly. Next question. Again, understanding based question. Assuming 2s 2p mixing is not operative. Assuming 2s 2p mixing is not operative, comma, the paramagnetic species among the following. Assuming 2s 2p mixing is not operative, the paramagnetic species among the following. Answer? So when 2s 2p mixing does not operate, in the beginning classes I have explained how 2s and 2p mix. Once 2s and 2p mix, what will happen to sigma and pi? What will happen to sigma and pi? So due to that mixing, what is happening to sigma? It is going up. In, suppose if this is 1s, sigma star 1s, sigma 2s, sigma star 2s. Up to 14 electron system, what is happening? Actually this should be the case, but due to mixing, this is going above. Due to mixing, that sigma is going above, and we are following this 14 electron system, up to 14 electron system. But what they are saying is, if 2s 2p mixing is not happening, if it does not happen, this is how you get the energy levels. Okay, this is how you get the energy levels if mixing is not happening. If mixing happens, this is going up. If mixing does not happen, it will be down only. Right? Now you give me the answer. So let us look at the options. Nitrogen. Nitrogen is 14 electron system. Whether this is above or whether this is below, it is fully filled only. Carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, now this is paramagnetic. Carbon is paramagnetic. So your answer is C2. B2 is paramagnetic. Originally B2 is paramagnetic. But in this case, if sp mixing is not occurring, what is the answer? C2. Because sigma is below pi. Okay, write down the next question. The compound with two lone pairs of electrons. This is a very easy one. The compound with two lone pairs of electrons. Without even writing, you can tell this. BrF5, BrF5, ClF3, XeF4 and SF4. It is, you are getting it as, which one? ClF3, compound with two lone pairs of electrons, ClF3, XeF4 also. So it is B and C. It is B and C. Okay, next question. For the given molecules, identify options where all four molecules possess permanent dipole moment. All four molecules possess permanent dipole moment. All four molecules must possess permanent dipole moment. Which one? B. All have permanent dipole moment. B and C. Some other options are B and C. Some are giving B and C. BC. So most of them are giving BC. In the last class, I have given you some geometries, whether that geometry possesses dipole moment or not. Based on that, first of all, you can analyze. Based on the geometries, first of all, we can analyze. But whenever there is a dissimilar atom, only then we have to be little careful. The first one is a TBP. Once it is a TBP, there is no dipole moment. It is 0. Forget about the remaining molecules. Okay. All the four should have permanent dipole moment. First one do not have. Second one has. SF6, pure octahedra. It does not has. XeF6, it may or it may not have. Because suppose if there is any distortion, it will have. If that is acting as an inert pair, it will not have. So anyway, first is not the option. NO2. In the last class we have seen NO2 radical. It was angular. So once it is angular, definitely it will have some dipole moment. So this has dipole moment. Ammonia has a dipole moment. POCl3 also has dipole moment. POCl3, it has permanent dipole moment. Ammonia also has a permanent dipole moment. CS3Cl, in symmetry wise, we say this belong to C3V. In symmetry wise, we say this belong to C3V, C3V and C3V point groups. Maybe if you are aware or not, but symmetry wise we tell any CNV type of point group will be polar. There will be a permanent dipole moment. So what they have given is this is C3V, this is C3V, this is also C3V. This one they have not given, but this is C2V, because if they are in conjugation, this can belong to C2V. Again, this is CNV. So CNV means polar point group. It is with respect to symmetry. But anyway, that unit is not there. At least you try to remember based on the molecular shape. But everything belongs to CNV type of a point group. Okay, write down another question. Match the following. Match the following. ClF3, XeF4, I3 minus and H2S. Lone pairs and bond pairs respectively at the central atom. First one, last. It is lone pair and bond pair. Because every time you go for bond pair and lone pair, in our discussion we go for bond pair and lone pair. One with three. First one with three option. First one. Okay, we'll work out. The more you practice, the better it will be for you. ClF3, it is T-shape. ClF3 is T-shape. ClF3 means you have already 3 bond pairs. How many lone pairs? 2. There are 2 lone pairs. This is a very important molecule. So ClF3, 2 plus 3. 2 is lone pair. Next, XeF4, 2 plus. There are 4 bond pairs. Directly answer is given. There are 4 bond pairs. F4, 2 lone pairs. So this is 3. I3 minus, we know it is linear. So there are 3 lone pairs and 2 bond pairs. So this is 4. 2, 3, 4. This has to be 1. Match the following. Now they are asking about hybridization. Question is about hybridization. sp3d, sp2, sp3 and sp3d2. Vamshi raised hand. You can answer. First one is CDAB. CDAB is the answer. So you got C. Okay, H2O is sp3. XeF4 sp3d2. It is molecular shape is square planar, but steric or electronic geometry is octahedra. IClF2. There are 3 bond pairs, there should be 2 lone pairs. So sp3d. Formic acid is sp2. Formic acid is sp2. Right. Okay, write down the next question. Among the following, the linear species is. Among the following, the linear species is. It is mostly those examples which frequently repeat. So once you are practicing more number of examples, they frequently appear. Question is, amongst the following, the linear species. D. Is D linear? Cl2O. A. Most options are with A. You blindly remember N3 minus is linear. It is azide. N3 minus is linear. NO2 angular. Ozone angular. Cl2O bent. It is bent. Cl2O again angular. Ozone NO2 N3 minus. Okay, next you just write down another question. Usually you find that in Telangana and AP, most of the questions, definitely 1 or 2 you will find assertion and reasoning type. Assertion means they will make a statement. Reasoning, this will be supporting that statement, supporting or related to that statement. Whatever statement that I have made, is that true? Is it related to the next statement or not? Or if it is unrelated, maybe both are true, both are false. That we call it as assertion and reasoning type of questions. So just write down a question. Assertion, the bond angle in water is the bond angle in water is 104.5 degree. The bond angle in water is 104.5 degree. Reasoning, the lone pair repulsion of electrons is higher than bond pair repulsion. This is a very simple question only, but how do reasoning and assertion questions will be, I am giving. First one, A is false but R is true. Second one, A is true but R is false. Third one, both A and R are true and R is the correct explanation of A. Fourth, both A and R are true but R is not the correct explanation of A. See, it is a very simple question, but how assertion and reasoning questions are asked, here I am giving you. So you have to correlate them. And most of the AP and Telangana, whatever exam that they conduct related to chemistry, definitely a few questions will be there related to assertion and reasoning. Okay, write down the next question. Which of the following are isostructural species? Which of the following are isostructural species? Which one? You just go through. Okay, okay. Now it is. So in the previous case, these were the molecules, He2 plus, He2 minus, beryllium anyway I have drawn. Which among the following species has unequal bond lengths? XeF4, BF4 minus, SF4, SiF4. Unequal bond lengths. First look at XeF4. Now we are known about the structure XeF4. Square plane. So bond lengths will be the same for square plane geometry. BF4 minus, it is a perfect tetrahedral geometry. BF4 minus is a perfect tetrahedra. If it is perfect tetrahedra, bond lengths will be the same. SF4, this is SF4, and SiF4 belongs to carbon, therefore it is tetrahedra. So this is also perfect tetrahedra, perfect square plane. It is a TBP. TBP yesterday I have discussed. Axial bonds are longer, equatorial bonds are shorter. So only thing you have to identify is the geometry. If at all it is tetrahedra or octahedra or square plane, bond lengths are same. But for TBP, bond lengths are different. So TBP can generate seesaw, TBP can also generate T-shape. Bond lengths are different in these three geometries, TBP, seesaw, as well as T-shape. Next one. Match the following. Match the following. Just after this, one more question. Match the following. In column 1, you write neon, nitrogen, F2 and O2. Bond order 1, 2, 3 and 4. A very simple one. Three, 4, 1, 2. 3, 4, 1, 2. So we are getting the answer as 3, 4, 1, 2. Neon does not exist, we know. So neon does not exist means that should be given 0. Nitrogen is also known, triple bond. Fluorine is also known, single bond. Oxygen is also known, double bond. So that is a very simple question. Okay, last question. Compare the bond angles. Compare the bond angles of H2O, H2S and H2SE. Compare the bond angles of H2O, H2S and H2SE. It is not like any option given. You just compare the bond angles. Does it increase? Does it decrease? Or does it remain the same? It will decrease. From the answers we are getting, it is decreasing. Okay, just let us take oxygen. let us take sulfur, let us take selenium. First guideline that you remember. What is this guideline? First of all, look at the electronegativity of the central atom. What is happening to the electronegativity of the central atom? We'll check. Electronegativity is dropping. From oxygen to sulfur to selenium, tellurium and polonium, electronegativity will drop. If this is more electronegative, whatever electron density that is present between the central atom and the bonded atom, that will be pulled towards the central atom to a greater extent. So just for convenience, I am putting it like this. Whatever electron density of the bond pair which is present is moving more towards oxygen because it is more electronegative. When it comes to the sulfur, sulfur is less electronegative, therefore less electron density is polarized towards sulfur comparatively. And when it comes to selenium, least polarized. It is least polarized. So in this case, when more electron density is flowing towards oxygen, what will happen to repulsions? Bond pair repulsions will increase. But when I am coming to this, what is happening to bond pair repulsions? Decrease. So bond pair repulsions are increasing, bond angle will increase. But in this case, the increase is very, very less because it is not highly polarizing it. So what is the conclusion? In which case bond order is high? What is the guideline? Guideline is, write down the guideline. Write down the guideline. You can just watch what is happening to the electronegativity. Decreases. As electronegativity of the central atom is decreasing, what is happening to the bond angle? Decreasing. Write down the guideline. As the electronegativity of the central atom decreases, as the electronegativity of the central atom decreases, comma, the bond angle also decrease. The bond angle also decrease. The bond angle also decrease. Let us come quite opposite. I am taking a central atom, same central atom, or else let me put it like this only. First, don't consider this. Let us just take two examples. Then I'll put it. Here is OH2, here is OF2. In which case bond angle is more? O? F2 bond angle is more. What is the reason? It is less. What is the reason? Electronegativity difference is low. Okay, write down the guideline. Then you will get the answer. As electronegativity of the bonded atom increases, as electronegativity of the bonded atom increases, as the electronegativity of the bonded atom increases, comma, bond angle decreases. Bond angle decreases. Bond angle decreases. How to remember? Central atom electronegativity increases, bond angle increases. Bonded atom electronegativity increases, bond angle decreases. So central atom is like directly related, bonded atom is like indirectly related with respect to the electronegativity and bond angle. So how to understand it? Between fluorine and hydrogen, which is more electronegative? Fluorine is more electronegative. So whatever electron density that is present between oxygen and fluorine, now it is moving towards fluorine. It is moving more towards fluorine. But in this case, this is more electronegative, but anyway we made it constant. Hydrogen is less electronegative. Hydrogen is less electronegative means less electron density is flowing towards hydrogen. Hydrogen is taking less electron density. It means here electron density is more. Here electron density is less. If electron density is more, what will happen to repulsions? Increases. So since repulsions increase, in this case, decreases. Because here, the electron repulsions have decreased. Because fluorine is more electronegative, it is taking away electron density. Electron density has decreased, therefore bond angle decreases. Here, fluorine is more electronegative. So electron density is going towards fluorine. Here, electron density is decreasing. So what is the second guideline? Whenever the bonded atom is more electronegative, bond angle decreases. So greater the electronegativity of the bonded atom, lesser is the bond angle. Higher the electronegativity of the central atom, higher is the bond angle. Central atom directly related, bonded atom indirectly related. Now let us include OCl2. We'll just close with that. What is the order? Which is having greater bond length. Oxygen is common. What is happening to electronegativity? From hydrogen to chlorine to fluorine, what is happening to electronegativity? Increasing. As electronegativity increases, bond angle decreases. Can you write down the order? As electronegativity is increasing, bond angle, what will happen to bond angle? Decreases. But this is expected. Found is something else. Found is something else. OCl2. Okay, with this we'll close. And why is this? We have to understand. In the first case, hydrogen. In the second case, chlorine. In the third case, fluorine. Electronegativity is increasing. That is fine, understood. But in chlorine, you have a d orbital. Fluorine do not have a d orbital. Hydrogen also do not have a d orbital. Whenever chlorine has the d orbital which is vacant, it can accept the lone pairs from oxygen. It can accept the lone pairs from oxygen. Since it is accepting the lone pair from oxygen, it is establishing a multiple bond. And that multiple bond will occupy a greater space. What is the domain of a multiple bond in comparison to a single bond? Domain is high. It will occupy a greater space. So what we are expecting is a single bond is not a single bond, it is a multiple bond. And multiple bond will occupy a greater space. So it will just move. Because it is a multiple bond, it will occupy a greater space. Both sides you don't find double bond at a time. Both sides you will not find a double bond at a time. It will be like double bond to this side. It will be more like a single bond, lesser double bond. Because if both are double bonds, you can expect it to be linear. It is not so. It will be like multiple bond, not a pure double bond. It is like a multiple bond which occupies a greater space. Therefore, OCl2 will be having a greater bond length. Sorry, not bond length, greater bond angle. Just make a note of it. Though expected series is according to electronegativity, difference, comma, in OCl2, the availability of vacant d orbital in OCl2, the availability of vacant d orbital establishes a multiple bond which occupies a greater domain. Establishes a multiple bond which occupies a greater domain. due to this bond angle, due to this bond angle increases exceptionally. Due to this bond angle increases exceptionally. Okay. So from the next class I'll begin with a new unit. You will be having a test, but after some time, though we have completed this unit very early because it is a very short unit, we will be taking up another unit, but test will be having maybe after a few days, not very early, right?